Problem 4-65. Find boundary points for each of the following inequalities. Draw the boundaries on a number line and shade the solution regions. Letter A, 3x plus 2 is greater than or equal to x minus 6. To find our boundary points, we're going to need to solve this for x, or isolate x in our inequality here. So you can treat it almost like it's just an equal sign there, but you're just solving it like you normally would an equation. So I'm going to go ahead here, I'm going to get all my variables on the same side and get all my constant terms on the other side. So since I have more x's on this side, I'm going to go ahead and subtract an x, subtract an x. I've got 2x plus 2 is greater than or equal to negative 6. Subtract my 2, subtract my 2. And we have 2 times x is greater than or equal to negative 8. Then to get x by itself the rest of the way, we know here we're going to divide each side by 2. And we get that x is going to be greater than or equal to negative 4. Now, we've got a number line here. We want to represent this on the number line. And you should have been doing this type of graphing probably back since middle school. Maybe it's been a while, so you need a little refresher here. Remember, this is talking about all the values we could plug in for x that would make this a true statement. So since x is greater than or equal to negative 4 is that boundary point. Okay, so if we're talking about our boundary point, we have a boundary point where x equals 4 here. I'm sorry, negative 4. So let's go ahead here and let's put this is negative 4. Now you can't just leave a number line with just one value on there. You got to make sure that you show that your number line is correct, which means you need a negative 3 or something that is greater than negative 4 on the right, and something that is less than negative 4 on the left, like negative 5. Now because negative 4 does satisfy, because we have this equal sign, remember equal sign means a closed circle. So we're going to put a closed circle on negative 4. And then we want to talk about shading which side. There's this region on this side to the left of it, and there's the region on the right side. We want all the values that are going to be greater than or equal to negative 4. So we know that our number line increases as we go to the right, so it should be that our shading goes this direction. And I'm just putting an arrow in there. Some of you like to shade in, make it pretty, that's fine. Now to test it, let's choose a value from this side and let's plug it in. I'm going to test it with the value 0. You'll find that 0 comes in handy quite a bit when you're testing a lot of these inequalities and equations. So let's plug in 0 here and make sure that it gives us a true statement in our original inequality. So let's do 3 times 0 plus 2, and that should be greater than or equal to 0 minus 6. 3 times 0 is 0 plus 2 gives us 2, and 2 should be greater than negative 6. So this is true, which means that we've shaded on the correct side here. So these values, everything greater than or equal to negative 4, is going to be a solution. Anything less than negative 4 will not be a solution. Let's move on to B. For letter B, we've got 2x squared minus 5x is less than 12. This one's a little different because it's quadratic, so we're going to have to come up with 2 boundary points on this one, in this case. There is a chance that sometimes you could end up with 1. You just got to make sure you work out the problem and see what's going on. I'm going to solve this just like it is the actual just equation. Solve like it is 2x squared minus 5x is equal to 12. If you solve it just like it's this equation here, this is to get your boundary points. So let's write that up here. To get boundary points, so you're going to solve like it is 2x squared minus 5x equals 12. So we should know how to solve these since it's quadratic and we have an x with a degree of 1 and an x with a degree of 2. That means we're going to have to set it equal to 0. So let's subtract our 12 from each side. And we now have 2x squared minus 5x minus 12 is equal to 0. Next step in solving this, let's factor it. Now, if you had a question up to that point and you haven't had a chance to factor it on your own, go ahead and pause the video, try to factor it and see if you factor it correctly. So I'm going to take it here. I already factored it, so I know what it's going to factor into. I have 2x and x, and then I'm going to have a plus 3 and a minus 4 in my right side. Now to get the boundary points, we need to finish solving this. We're going to say 2x plus 3 equals 0 and x minus 4 equals 0. Using the zero product property, we're going to figure out what values of x would make this a true statement. So when I take that and I set this equal to 0 and I solve it, I should get x equals negative 3 halves or negative 1.5. And this one would be x equals 4. Okay, so we have that or that. Now, remember, this does not contain an equal sign, which means when we put our boundary points on our number line here, we are going to put, let's put our one that's less, negative 3 halves, should be on the left. 4 is more, so it needs to be on the right side. Because there is no equals sign, okay, remember, there is no equals, so we're thinking that this is going to be like not equals, or which is going to be an open circle. We need to put an open circle at the boundary points. So remember, these are our boundary points. Okay, so we got negative 3 halves and we got 4. That's where they end up being here. In order to figure out where our solutions lie, we have 3 regions we have to test. We have to test this region, and this region. Chances are it's either going to be both of these ones on the outside or it's the one in the middle. Well, the value that I always like to test first is 0. I'm going to test 0 here because it's in between. But you could test something like, say negative 2. You could test 5 if you want to. Let's plug them in here and let's see what happens. I'm going to test them all just because this video, this concept might be new for somebody here and you want to make sure you understand what's going on. So I'm going to test negative 2 first. So I'm going to say here 2 times negative 2 squared minus 5 times negative 2 is less than 12. Let's see if this is true. Negative 2 squared is 4. 4 times 2 is 8. And then we have minus 5 times negative 2, so this would be like saying plus 10 is less than 12. And we get 18 is less than 12, which is false. So this is not a solution out here. There are no solutions. That means that 5 probably won't work either. Let's see if that is true. Let me move my little box over here. Let's do for 5, we're going to say 2 times 5 squared minus 5 times 5 is less than 12. 5 squared is 25 times 2 is 50. 50 minus 25 is going to be 25, and 25 is less than 12. That is false as well. That does not work. which means that these are not solutions out here. So the last part we need to look at is this one. So I'm going to choose 0 here, and I'm going to plug it in. Let's see, I might need to move it down a little bit. I'm going to say here, for 0, I'm going to say 2 times 0 squared minus 5 times 0 is less than 12. 0 squared is 0. 5 times 0 is 0, so we end up with 0 is less than 12. That is true. That means that this is a solution, and you get to put a little smiley face. So let's go ahead here and let's mark it on our number line here. We're going to say everything that is greater than negative 3 halves. So we can say x is greater than negative 3 halves, and it also has to be less than 4. So we're going to say and x is less than 4. That's one way to write it. Or you can flip this one around and throw your x in the middle. We could say negative 3 halves is less than x, which is less than 4. So either one of those would be correct there if we were writing inequality as an answer. This is the number line. This is problem 4-65. Hopefully that helps you. Remember, the boundary points are those values you get when you solve it for the variable there, so you know where to put them on your number line. If you have questions, make sure you ask your teacher or seek help from somebody. Thanks for listening.